Good morning, dear students. Today we are going to study the third unit. We are going to start the third unit, that is signal conditioning circuit. Okay, third unit, signal conditioning circuit. Under that, we are going to study about bio amplifiers, impedance matching circuit, isolation amplifier, power line interference, right leg driven ECG amplifier, and bandpass filtering. So today we are going to discuss in detail about need for biological amplifier and about the differential bio amplifiers. Okay, let's see in details. So what is the need of bio amplifiers? Okay, so we all know there are voltage, that is the potentials is picking from the human body, right? So these potentials have low amplitude as well as low frequency. So just to increase this amplitude level, we are using bio amplifiers. Okay, so the signals that are picking up from the body have low amplitude as well as low frequency. So just to increase the amplitude level, we are using this bio amplifiers. Okay, that is the output from the amplifiers are used for further analysis and they appear as ECG, EMG or any other bioelectric waveform. Okay, so these type of amplifiers are defined as bio amplifiers or biomedical amplifiers. So what is the use of bio amplifiers? Just to increase the amplitude level of the biological or bioelectrical signal that is picked from the human body. That signals have low amplitude as well as low frequency. So just to increase the amplitude level, we are using this bio amplifiers. Then these are the requirements for the bio amplifier. So if you are taking a bio amplifier, it must have these requirements. Okay, that is the impedance value must be high. So just to reduce the noise, the impedance or the distortion in the signals, the impedance value must be high. That is, the range of this impedance value is from 2 mega ohm to 10 mega ohm. So if the value is in between these, means we can say the impedance value is good for this biological amplifier. So when the electrodes pick up the biopotential from the human body, the input circuit should be protected. Okay, so normally these bio amplifiers should consist of two circuits, that is isolation as well as protection circuit, just to prevent the patient from electrical shock. We all know these are the electronic components, so there is a chance for getting shock. So we are using two circuit named isolation as well as protection circuit just to avoid the electrical shock to the patients. Okay, since the output electrical signal is in millivolt or microvolt range, the voltage gain value of the amplifier should be higher than 100 dB. Okay, so if the output of the output of this signals is in millivolt or microvolt range, means the voltage gain will be higher than 100 dB. So throughout the entire bandwidth range, a constant gain is maintained. Okay. The bio amplifier should have small output impedance. We know these bio amplifiers have high input impedance just to avoid the noise or distortion in the signal. So we can see this have small output impedance. A good bio amplifier should be free from drift and noise. Okay, if we can say amplifier is in good if it is free from noise as well as drift in the signal. Okay, next another term, common mode rejection ratio. What is common mode rejection ratio? It is the ratio of amplification. There will be two types of voltage, differential voltage as well as common mode voltage. So the ratio between the amplification of differential voltage as well as the amplification of common mode voltage is called as CMRR. Okay, so the value of the amplifier should be greater than 80 dB just to reduce the interference from the common mode signal. The gain of the bioamplifier should be calibrated for each measurement. Okay, these are the requirements needed for the biological amplifier. Next, types of the biological amplifier. Bioamplifier. Here we are using a differential amplifier, operational amplifier, instrumentation amplifier, chopper amplifier, and isolation amplifier. These are the types of amplifiers. Okay, in this chapter we are going to study about differential amplifier as well as isolation amplifier. Next, we are going to see in detail about differential bio amplifiers. Differential amplifier. What is a differential amplifier? Differential amplifier is a device which is used to amplify the difference between the voltages applied at its input. Okay, so just to amplify the difference between the voltages, here in this differential amplifier we are giving two input. So this differential amplifier is used to amplify the difference between the voltage applied at its input. Okay, normally, this differential bioamplifier can be classified into two types, that is, by differential amplifier using transistor, or by differential amplifier using operational amplifiers. These are the two types of differential amplifiers that we are using. Okay. First one, differential amplifier using transistor. Here we are using BJT as the transistor. Okay, here in this figure, Q1 and QT are the two transistors. Bipolar junction. Here we are using bipolar junction transistor, and here we are using two power supply, that is VCC as well as VEE. That is the polarity of this is in opposite side. Okay, that is here if we are using VCC means here minus VEE, so it has opposite polarity. Normally in this we are using three resistors. Okay, two 4 collector resistance, two resistance, that is R1 and R2 act as the collector resistors, and we can say one emitter resistance. Okay, that is this RE, which is common to both the transistor. Okay, here the input signal, that is V1 as well as V2, these are applied to the base of the transistor. When the output is collected across the here the output, that is V01 as well as V02, it is collected across the collector terminal. Okay, so the input is given to the base, and the output is collected across the collector terminal. Next, okay, this is the differential amplifier using BJT. Then differential amplifier using op amp. What is op amp? It is the operational amplifier. Here, an operating amplifier in differential mode can readily act as a differential amplifier. So there are two modes, right? A differential mode as well as common mode. If an op-amp, operational amplifier, is operating in differential mode, we can say it is a differential amplifier. So the output of that is V0 is equal to AD into V1 minus V2. What is V1 minus V2? That are the input voltages applied to inverting as well as non-inverting terminals. Okay, what is AD? That is the differential gain. So the output of this operational amplifier V0 is equal to 0 when the input voltages are equal. Okay, if V1 is equal to V2 means we can say the output V0 is equal to 0. Okay, so the mathematical expression for the output of the differential amplifier can be given as V0 is equal to AD into V1 minus V2 plus AC into V1 plus V2 divided by 2. AC is called common mode gain of the amplifier. This is the output of the differential amplifier. Okay. Okay. This figure shows the differential amplifier using operational amplifier. Okay. The functionality good. The differential amplifier are expected to exhibit a so this is a differential amplifier using op amp, right? So this must have a high common mode rejection ratio and high impedance. Okay, this must have high common mode rejection ratio as well as high impedance value. So the differential amplifier circuit is just a combination of inverting as well as non-inverting amplifier. We know this differential circuit using op amp or differential amplifier is just a combination of inverting as well as non-inverting amplifier. So the output voltage will be equal to the sum of voltage produced by the open circuit operating in inverting as well as the operating circuit operating in non-inverting amplifier. We know here we are using inverting as well as non-inverting amplifier. Okay, so the output is the sum of, here we are getting the output from the non-inverting terminal as well as the output from the inverting terminal. So the total output voltage is equal to the sum of both the output from the inverting as well as the non-inverting amplifier. So the output V0 is equal to RF by R1 into V1 plus V2 into RF by R2 plus R3 into 1 plus RF by R1. What is RF? That is the feedback resistance which we are using. Okay. If R1 is equal to R2 and R3 is equal to RF, then we can say V0 is equal to minus RF by R1 into V1 plus V2 into RF by R1 plus RF into R1 plus RF divided by R1. Okay. So in this, the differential amplifier is operating in various modes. Okay, so just see about the different modes of operation. Okay, first one is single entered mode. Okay, we all know there will be two inputs. What are the two inputs? V1 as well as V2. Okay, if either of this input is equal to 0, the operation of the differential amplifier is known as single entered mode of operation. So we know there are two inputs, that is V1 and V2. If V1 is equal to 0 means it acts as a non-inverting mode, and if V2 is equal to 0, we can say it is an inverting amplifier. This is called single-ended mode. That is, we are just using a one terminal goes to 0 and we are using only one terminal. So it is called a single-ended mode. Next one is the differential mode. Okay. In this differential mode, that is there is a differential between the two signals. So in this mode, the two input signals are equal but have opposite polarity. The polarity will be opposite to the first one. Suppose if we are taking V1 as positive, then V2 is equal to negative. So in this differential mode, V1 is equal to minus V2. Both signals are equal but have the opposite polarity. So we can represent the output voltage V0 is equal to minus RF by R1 into V1 plus V2 into RF by R1. In general, we can write this as minus RF by R1 into V1 minus V2. So the gain of the differential amplifier circuit is shown in the above figure. So the gain, this RF by R1, that is the gain of the differential amplifier. What is RF? that is the feedback resistance. Okay, here this is the RF and this that is the feedback resistance. So here the gain is RF by R1 minus RF by R1. Next one, common mode. Okay, well, so the differential modes, both the input voltages have opposite are same with opposite polarity. So what about the common mode? Here we can say the input voltage are identical in amplitude as well as the phase at every instance of time, and circuit is said to be operating in common mode. Okay, the input of the signals are called common mode signals. That is, we can say V1 is equal to V2. That is, here the amplitude as well as the phase at every instance of time are said to be operating in common mode. That is the common mode. Next, common mode rejection and differential amplifier. What is common mode rejection? So it is a ratio of the differential voltage gain AD to the common mode voltage gain AC. Okay, ratio of differential voltage gain AD to the common mode voltage gain AC, that is equal to amplification of differential voltage divided by amplification of common mode voltage. This is normally represented using decibel. So normal CMMR in dB is equal to 20 log CMR. This is the common mode rejection and differential ratio. Okay. Hope you all understand the topic differential amplifier. Thank you. If you have any doubt, you can WhatsApp or comment. Okay. Okay. Thank you.